Okay, so first let's take a look at your homework. Last night I asked you to do this math review sheet. Okay, and so the first part is just rearranging. So the first one, it wants you to rearrange d equals vt for v. So you want to get rid of the t on both sides. So divide both sides by t, and you're left with v equals d over t. For b, you still want to rearrange for v, so you want to get it off the bottom. So multiply both sides by v. So you'll have vt equals d, and then divide both sides by t. So it'll become v equals d over t again. All right, the next one, rearranging for v. So you want the v alone, the 2d is on the bottom. So multiply both sides by 2d to get rid of it, and they'll cancel. And so you'll have v squared is equal to 2dA, and then of course you need to take the square root of both sides. So v will equal plus or minus root 2dA, and you can't do any more than that. And then over here, still rearranging for v, so you want to get rid of the a, so to get rid of the a, multiply both sides by a. And so it'll become v is equal to ab over c, and you are done. All right, for the next one, you want to rearrange to solve for e. So we want to get rid of the s, so multiply both sides by s, and this becomes e equals fs. Next one, you're rearranging for e, so multiply first both sides by v squared. So it'll be 2e equals mv squared, and to get rid of the 2, divide. So then it becomes e is equal to, and we usually write it as 1/2 mv squared. You might not recognize this equation, but you'll see it before the end of the course. It's E is energy, and so it's for kinetic energy, energy of motion of an object. But you can forget that until we get there. And then this one, rearranging for E, multiply both sides by c squared, and you get E equals mc squared. And you might recognize this one. This is Einstein's equation. And if you were in my classroom, you could look up on the wall, and it's there. E is energy, m is mass, and c is that speed of light that we've been talking about, the speed limit of the universe. And so this tells us how much, a given mass, how much energy it would convert into if you can convert it completely into energy. And for more on that, you need to take a course next year called Science 12.2. All right, solve this equation for d. So to get the d alone, subtract vi squared from both sides. So it'll be v squared minus vi squared is equal to 2ad, and then divide both sides by 2a. So it becomes d is equal to v squared minus vi squared over 2a. Write in scientific notation. So remember, you want to move the decimal so that the number in front is between 1 and 9. So we're going to move it to here, so it'll be 6.03. And you need to keep the same number of significant digits as the question has. These last 3 zeros aren't significant because there was no decimal, so it'll just be 6.03 times 10 to the 1, 2, 3, 4, 5, and it's positive because we're moving it this way, a bigger number, so meters. We're moving it to the left. For b, we're moving it to the right, so it's going to be a negative exponent. 1, 2, 3, 4. So it'll be equal to 6.4 times 10, and we're moving it to the left, so negative 4 meters. And there's only 2 sig figs here. These leading zeros don't count. Okay, so 6.4 times 10 to the negative 4. All right, oops, sorry, my hand somehow got in the way there. Next one, again, these zeros at the end don't count, so it'll just be 3 significant digits. Move your decimal, 1, 2, 3, 4, 5 again. So it should become 7.83 times 10 to the 5th grams. And again, positive because we're moving it to the left. And the last one, moving right again, and we're just moving it 2 spots, and it's only the last 2 digits that are significant, so 1.8 times 10 to the negative 2 centimeters. Okay? The next question wants to know how many sig figs do each of these have? So this 0 in the back in A is going to count because it's after the decimal. Start from the first non-zero number furthest to the left and count right. So 1, 2, 3, 4, 5, 6. So this guy has 6. Okay, all of them count. In B, no decimal here, so this in 0 doesn't count. But the ones in the middle do. So this one has 4. Decimal in this one, so the in 0 counts. So 1, 2, 3, 4, 5 again. Decimal here, so the in 0 counts, but the leading ones don't. Remember, go to the number that's furthest to the left, non-zero number, and count to the right. This one's going to have 4, starting with the 4 and going right. In E, there's a decimal at the end of this guy, so now the in 0 does count. This one's going to have 5. In F, the times 10 to the 4th, they don't count in the sig figs. It's just the number itself. So it's just the 3, the 6, and the 2. This one will have 3. No decimal in this guy, so the final 0 doesn't count, but the 2 in the middle do. It should have 5. The scientific notation part doesn't count here, just the ones in front. There's a decimal, so the in 0 does count. This is going to have 3. And the in 0 here does count because of the decimal, so they all count. So 3, 4, 5, 6, 7. And the last one, no decimal, so the 0 does not count. This one's going to have 4. And I don't know if you noticed, but J and B look an awful lot alike. When I typed it up, I must have had a plan for J, but I don't remember what it was because it looks like B. So sorry about that. All right, this next one. Write your solution to the following using significant digits. So first you need to add the 3 of them together. And when you add the 3 of them together, you get 14.106, I believe. And now you look at how many sig figs, what can you keep? So in adding, it's the number of decimals. So the first number has 3 decimals, the second number has 1, and the last number has 2. And you're only allowed to keep the same as the least number of decimal places. So this one only has 1 decimal. I can only keep 1. This is going to be 14.1. Okay? And the next one I'm multiplying. So when I multiply these two together, I get 28.6578, I believe. And so then I look, this time it's the smallest number of significant digits. So the 32.94 has 4, the 0.870 has 3. I'm only allowed to keep 3. So it's going to be 28 point, and it can't just be 6 because the next number is 7. Or next number is 5, excuse me. So I have to round up to 7. So it's going to be 28.7. 3 because of the least number of sig figs here. Okay, the next one is dividing. So when I divide, I get 8.0176. And in dividing, it's the least number of sig figs. So the first 40.89 has 4, 5.1 has 2. I am only allowed to keep 2. So it'll be 8. You look at the 0, the one beside it is a 1. It doesn't round up, so it's just 8.0. Okay? Convert the following. So we're going to be switching from one to another, and you're going to need that conversion factor. Okay, so first one, 3.9 meters. We need to multiply by something so we can get to kilometers. Okay, so we want kilometers on the top. That'll mean meters on the bottom. Put a 1 on the larger one. How many meters in a kilometer? It should be 1,000. And so when you do this, you should get 0.0039, or 3.9 times 10 to the negative 3, if you want to write it out that way. 3.9 times 10 to the negative 3 kilometers. I'm going to run out of